everybody? All right, real quick, can you hear me? Give me a thumbs up if you can hear me. Thumbs up if you can hear me. Let me know. Okay. Excellent, excellent, excellent. Looks like we got a good group today. Got 15 here, 17 here. That's excellent. Everybody knows the test is coming. Hopefully I didn't scare any of you too much. Happens to me when I look in the mirror all the time. You already know that. All right. So again, first things first, I must apologize. I forgot to post the assignment for the review until I did it late last night, about 9:30 or so. I know that's early for all of you. For me, as an old fart, that's pretty late. So that test, or excuse me, that is up there. So again, my apologies to that. I will do some questions from there. I'll let you all, have your textbook open. We'll take a look at it. We'll do some questions from there. You'll have the weekend to do your reviewing on your own, and our test will then take place on Monday. Now, my plan on Monday is to actually come and do a quick live feed, see if there's any final questions before we move into the test. Then I'll open that test and we'll have it on its way. So hopefully that works for everybody. Monday is our test, yes. Okay? All right, so at this point in time, first thing we're going to take a look at is we're going to take a look at the quiz. Now, again, I had an apology there as well. I've already adjusted scores because I had an incorrect typo. I had a typo mistake on, I don't remember which one it was, but it was one where the answer should have been 14, and I had 4. That was a typo mistake on my part. I think that was maybe this one. Okay. All right. So from here, everybody, let's take a look at the answers to the quiz real quick. Now, as we do this, now keep in mind that there are a couple of people that haven't taken this yet. I don't know if they're in the room. I haven't seen that yet. So please do not pass it along to somebody because, again, we want to try to make sure that we hold the honor to everybody in terms of their quizzes. So without further ado, here we go. So looking at this problem here. Now, again, some of you might have been randomized just a little bit on that matching part, which would have been these 3 problems. So it might have been randomized a little bit, so they might have been a different order. Okay. Blessing, I will get to those in a little bit. Let me get through the quiz first, and then we'll do this, okay? All right, so from here, in the first problem, whichever one this was for you, the problem where we had the fourth root of the fourth root of 9x plus 18 is equal to 3. In this particular problem, first move, fourth power. Okay, so taking it to the fourth power, fourth root, fourth power, undo, that leaves us with just 9x plus 18 is equal to 3 to the fourth power, which is 81. Then from there, now I've got to subtract 81 from that. Okay, so 81 minus 10 is 71. 71 minus 8 is 63. Division by 9, we'd get that x is equal to 7. If I check it back in here, 9 times 8 is 72. 72 plus 18. And then fourth root of that, we will end up with 3. Okay, because this will be 72 plus 18 is 81, or 63 plus 18, 81. Fourth root of 81 is 3, so 7 works. All right, in this problem, can't do anything with the 3, so the first thing I've got to do here in this problem is I have to go ahead and take it to the third power. Now, common mistake that gets made here is people forget that the 3 here also is taken to the third power. So I'm going to have 27 times x plus 4 is equal to 2x minus 17. Okay? Then from there, now I'm going to go ahead and distribute the 27. So I'm going to get 27x plus, let's see, that's 80 and 28, so 108 is equal to 2x minus 17. I'm now going to subtract 2x and subtract 108. So 27 minus 2x is 25x. Negative 17 and negative 108, that will be negative 125. Division by 5, or excuse me, division by 25, we get x is equal to negative 5. Okay, so in that particular problem then, again, if I go back and check my answers here, I've got negative 5 plus 4 is negative 1. Now that is okay here because it's to a cube root. It's not a square root. So the cube root of negative 1 is negative 1 times 3 is negative 3. If I check it over here, 2 times 5 is negative 10. Negative 10, ooh, hang on a second. Bear with me here for just a second. Yeah, that's right. Okay. Negative 10 minus 17 is negative 27. Cube root of negative 27 is negative 3. So we have another answer that works here. Okay. In this problem, again, this was the problem I believe that I made a mistake on here. So as I do this, first thing I can do is I'm going to divide by 4. So that's going to give me x minus 5 to the 1/2 power is then equal to 3. From there, now I can square both sides. Okay, again, I could rewrite it if I want to. I don't need to. Okay, I can leave it the way that it is. And then from here, this would give me x minus 5. 2 times 1/2 in those powers is 1. So I don't need to write it, which allows me just to the x minus 5. 3 squared, which is 9. Now, this is where I had the typo. I missed a 1. I got to add 5. So x is equal to 14. So the way that I did that is those people who ended up with a 4, I took that and I corrected it. And so I adjusted your scores to reflect that situation. Okay. Now, in the last problem, we are doing things with a calculator here. Okay. So in this particular case, I'm looking to find the volume when my radius is 32. So I'm essentially plugging in the 32. So 32 is equal to the cube root of 3v over 4 pi. Now, what I'm going to do here to get the most accurate answer that I can, and I will go back and I'll take a look at those because I know there were a couple people that were really close. So I'm going to go back and I'm going to take a look at some rounding answers because I know I didn't do that yet. So bear with me. I might be making a couple of changes to scores. The idea here is that I'm betting some people probably use 3.14 rather than using the pi symbol. So I get that. So that might be a little bit of variance in terms of an answer. I'll go check that. All right. So in this particular problem then, in order to solve it, I'm going to have to take everything to the 3rd power. Now, what I'm going to do here to try to keep this as accurate as possible is I am actually not going to do any of these calculations until I have isolated v. So I'm going to leave the 32 to the 3rd power alone, but I do recognize here that the 3 and the cube root will undo each other. So that's going to give me 3v over 4 pi. Now, from here, as I work this, the first thing I want to try to move is going to be the 4 pi. Now keep in mind, that's a division here. So as I do this, I'm going to multiply by 4 pi to both sides. So I'm going to visually show this here just so that we can see where everything pops out of here. So again, what happens is I lose the 4 pi's, but notice what remains here is a 3v. Okay? So essentially, Now what I've got is I've got 4 pi times 32 to the third power is equal to 3v. One last step, that's a division by 3. And now the expression that you're seeing right here is what I would need to calculate. So when you throw that into your calculator, using the pi symbol, you're going to get one number. If you use 3.14, you're going to get a little bit of a different number. So again, I will go back and I will check that, and I will see where things are at from there. And again, I'll make adjustments. Now, some other adjustments that I made is we had some people who tried to put in a label, and so it didn't take that because I had it as just the number. I didn't specify that, so that's my mistake. So I went back and I looked at all the answers and I adjusted those as well. So I know some of you might have been upset a little bit going, hey, wait a second, I did that right. And you know you did it right. It's okay, I got her adjusted. So, okay, so give me a thumbs up if that makes sense for the quiz here, and then we'll move on to the questions. All right, Zari, I see the one comment you made, and that's perfectly okay to make calculations early. It's just we have to keep in mind. And again, I'll go back and look at your quiz. I'll take a look at the different possibilities that came up. I'm guessing you probably calculated the 32 to the third. You might have calculated the 4 pi here and rounded. So we'll take a look at some rounding errors and see how close we are. Okay, looks like people are doing okay with this. Excellent, excellent. Okay. All right, so I'm going to have to scroll back up here because I know there were a couple of questions that have already been asked for the review, so I will start with those. All right, so before I actually get in and do any of the review problems here, so I know I see 70 and 83 listed, so I'm going to write those down. All right, I want to see just a quick, give me a quick smiley emoji if you were able to get some of the problems done from the review before you got here. Just give me a smiley face emoji. Oh no, only one? Oh, there they come. Now they come in. The wonderful lag in our live stream, isn't it? Okay, this is looking good. Excellent, 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 excellent. So just as we're kind of getting ready to move here, I did hear a joke the other day. It was actually a message that was sent to me, and it read in there. It was kind of a little display, and it said that school is going really, really well. That 2 students were suspended for fighting, and 1 teacher was fired because they were drinking on the job. Not me. All right. So looking at problem 70. Start there. All right. So problem 70, we have to solve the equation. We have the cube root of 2x minus 2. All of that is over 6 is equal to 1. Okay. So in this problem, in order to start getting at this, I have to isolate the cube root. So the issue is I've got to get rid of this 6. So to do that, notice that 6 is in a denominator, so it's acting like a division. So essentially, I can multiply by 6 on both sides. Now, I'm going to be a little more visual here because I know that this is a little bit different from what people have seen, so perfectly fine, we'll adjust. So now what's going to happen is the 6's will reduce, and that gives me the cube root of 2x minus 12 is then now equal to 1 times 6, or 6. From here, now I need to undo the cube root by taking a cube. Now, don't overthink this step. Okay, don't overthink this step. Whatever your index value is what you're going to use as your power. The index and the power are what are essentially offsetting each other. So don't overthink that step. Okay? Let the visual cue be there for you. So then from here, now we'll get the 2x minus 12. 6 to the third power, I believe, if I'm not mistaken, is 216. I know it's 36 times 6. So there's a 6, carry a 3, 18, and 3 is 21. So that is the correct result there. Now I'm just ready to start solving. So 2x, 216, we're going to add 12 to it, so that looks like 228. Okay? Division by 2, we're going to get x is equal to 114. Okay, now don't overthink that one either. Essentially, since I know that these are all even numbers, I know every one of them divides perfectly by 2. That's how I'm getting at as quick as I am. So I know some people that you may not process it the same way. Now, if I go ahead and check this, that answer should work here. Okay, that answer should work here. Now, as I do this, I'm taking 2 times 114, which is 228, and I'm subtracting 2. 228 minus 2 is then 226. The cube root of 226 divided by 6 will end up being 1. Okay, so you have to trust that work a little bit, but it should work. Okay. Wait. Is it not a 12? Oop, I wrote a 12. It should be a 2. Whoa. Good catch. Let's try that again. Good catch. My mistake. 2x minus 2 is equal to 216. 2x is now equal to 218. Let's try that again. X is equal to, in this case, we're looking at 109. That a little better? Give me a thumbs up on that. And yes, I can be very tired at times. I'll tell you, my mind is racing, trying to make sure I've got everything done to make sure it's working for all of you. So all this right here, your fault. Okay, so again, thanks again for pointing out the mistake. Just do that just like you did. That's perfect, because I'll catch those as they come in. All right. Good. Let's move on to 83. Just think, if I had to pay you $1 for every time I made a mistake on the board. 83. Okay. So in this one, we got the time in seconds required for a pendulum to complete one back and forth swing. So let's just make sure we understand what that is. Pendulum is like if I take my arm and I do this. That's acting like a pendulum. If you can picture like an old grandfather clock, that would be considered a pendulum. Okay? All right, so in this, they're giving us the time in seconds for a pendulum to complete a back and forth swing. So it's going from one back to the other, essentially. They give it as a formula. T is equal to 2 pi times the square root of what they're saying is L, capital L, over 9.8, okay, where they're saying L is the length of the pendulum. Okay, so in this one, then what they're doing is they're saying estimate the length of the pendulum that completes one back and forth swing in 2.5 seconds. So what's happening here, this is actually very similar to that application problem that you had on the quiz. Okay, so we're going to go ahead and put in that 2.5 seconds here for T. Okay? Now, from here, my goal is now to start isolating the square root here. So the first thing I'm going to do is divide by 2 pi. Now again, I can make this as accurate as possible if I don't use 3.14. Okay? So I'm going to leave everything alone before I do my calculation, because then what I can do is that I can type it into my calculator exactly as I see it here, which will guarantee the most accurate result. So after dividing by 2 pi, that gives me the square root of L over 9.8. All right? So now from here, I need to get rid of the square root so I can get it just the quantity on the inside. So I'm now going to square both sides. Now again, keep in mind, if you do use 3.14 here, your answer will be off a little bit, and the more manipulation that you do to it, the bigger the error will become. Okay? So that's where I'm going to recommend holding off on that. All right, so square root squaring is going to leave us with that L over 9.8. Now again, 9.8 is a division here. So to get rid of that, it's a multiplication to both sides. So what I've got to be careful of, don't get this 9.8 on the inside with that squaring. When I write this and I type it in, I want to make sure I type in 9.8 and then do a parenthesis and do 2.5 over 2 pi, close the parenthesis, and then make sure you square it after that. This is one where an error could be very easily made if you didn't set it up correctly in the calculator. Again, the calculator is only going to do what you tell it to do. So if you end up typing it in incorrectly, that's going to be your issue. So if you are looking at it from, let's say, the iPad calculator, the way that it would look when you start, if you were to try to set it all up before putting numbers in, you would essentially make it look like this. Okay? So you might want to practice that a little bit, but that should then get you to your results. So I'm going to grab my calculator here real quick, and let's see if I can actually do this. So, all right, so I've got 9.8, and I'm going to multiply that times, let's see, am I going to be able to get a fraction here? Yes. So I'm going to type in 2.5. I'm going to toggle it to the bottom. Now I got to find my pi symbol. Oops, excuse me, backwards, 2 pi. And now I'm going to toggle over, close that parenthesis, and now square it. Okay, now I'm not going to be able to make this real big, but I want you to be able to see here. That's what it should look like when you type it in. Okay? So when you get it typed in like that, it'll guarantee your exact answer. And then from there, I'm getting 1.55. Okay? So, and again, they said in this case, they want it to estimate the length that completes it. So they're not labeling or saying a specific decimal to go to. So in this case, we're looking at 1.55, and then they're saying that the length of the pendulum is in meters. So that would be 1.55 meters for that final result. Okay? All right? Let me know if that makes sense to you. Okay? Let me know if that makes sense for problem 83. Or if you have a question, just post your question on it. All right. Looks like we're good. All right. Cindy, looks like we're doing 84. Sodika. All right. 84. Okay, so in this one we have a tetrahedron, which is a triangular pyramid with 4 congruent faces. So in this one it says the side length is given by a formula. So the side length S is given by the formula 6V square root of 2. And all of that, make sure I'm writing it correctly, all of that is raised to the 1/3 power. Okay? Now I want to make sure I'm betting V is volume. And that's a volume in cubic meters. Now again, I'm keeping that in mind for label purposes. That means that my side length would be in meters. Okay. All right. So from here, now, it says what is the volume with a side length of 8? So we're going to go ahead and plug in the 8 for the side. And now I've got 6V radical 2 to the 1/3 power. Okay. So in this case, the nice thing about this is that the first thing I have to eliminate in order to get at V is I need to get rid of that 1/3 power. So think of this, I could change it and write it as a cube root. I'd be perfectly fine. No problem with that. I'll be honest, I think that's an extra step we don't need if we recognize that the denominator acts as our index value from when we converted back and forth. So I can look at this and say, all right, I can eliminate the 1/3 power by raising that entire side to the 3rd power. Being fair to both sides of equal sign, raise that to the 3rd power. Now I can calculate 8 to the 3rd. Let's see, 8 to the 3rd. Don't know that one right off. 512. Okay? Now on the other side, the 3 and the 1/3 essentially will multiply to make 1, so I don't have to list it. It's an exponent of 1. It eliminates. So it leaves me with 6 times the volume times the square root of 2. Now, in this particular case then, we're kind of dealing with the same issue here, is that they're going to ask for something rounded to the nearest 10th. So again, I don't want to type this in yet until I'm doing the divisions over here. Now, as I do this, I think what I'm going to do is I need to isolate V. So I'm going to physically show this one. Normally I wouldn't do that, but we're going to divide by 6 and divide by the square root of 2. So my volume would be calculated by doing 512 divided by 6 radical 2. Now, a common mistake that gets made when we go to calculate here is that we do 512 divided by 6, and then we say 6 times the square root of 2. And so what that's actually doing is if I do 512 divided by 6 and then times radical 2, the division here is being performed and taking that result times the radical 2. So again, using the iPad calculator, what I want to do, see if I can actually do this here. Okay, so what I want to do in this particular case is I want to get my fraction bar up here. Okay, get my fraction bar. And now I'm just going to type in the 512 in the numerator. Okay, so it's now looking like that. And then go to the denominator. And now you can type in your 6 root 2 like this. Okay, that guarantees that the calculator will handle it correctly. And then from there, we now have our value. Okay, so we have a volume here that is saying 60.33. Now I'm going two places because it says to round to the nearest tenth. So essentially I'm looking at the 3 to tell me what to do in the tens position. So this would be 60.3, and then again, label as cubic meters. So I could say meters cubed. Now, bear with the fact that in the assignment, they might have used 3.14. That is one thing that the textbook is pretty vague on in terms of how they're actually using radicals. Okay, they might say radical 2 is 1.41 or something like that, and so they get a little bit different answer than what we're getting here. So the way that I'm working with you is to get it as close to exact as possible. Okay, so you got a volume of 128. All right, so that tells me I made a mistake. Is that what we're saying here? Unless I'm looking at the wrong problem. Let me look back at it here. Maybe I made a mistake. So I've got the right problem. I've got the correct answer, yes? All right, I got to look here real quick. I know there's a delay here. Okay, right answer is 60.3. Good. Okay. So, Cindy, you were asking, is there another way to solve the problem? Really, the only other thing that you could do, and this would be from the step that I've written in black here, is you could do this. That would be about the only move you could make, or you could make it really ugly. You could say this: 8 is equal to 6 to the 1/3, v to the 1/3, and then I could say that the radical 2 could be 2 to the 1/6. But I'm guessing you don't want to go that route. Okay? Okay. So blessing. All right. I have a feeling. Okay, so you said 128 times 2 to the 1/2 all over 3. So what you did is I think you rationalized it and left it exact. Okay? So here's what's going on. If I'm recognizing what you're doing, you're working from here and you're doing a little work with the radical 2. Okay? So this would be a correct answer for an exact. So if you did this, that would give us 512 radical 2 over what would be 6 times 2, or 12. But then I would need to reduce this. And so I'm looking at that. I think that's going to reduce by 4, if I'm not mistaken. Okay, so that's where your 128 is coming from, all over 3. So that is a correct answer as an exact value. Okay, so you'll notice that in the directions it does say to take it to the nearest tenth. So really, all you have to do is put it into a calculator, and you're good to go. Okay, you're that close. Okay, good job. Good job. Okay, any others that we want to take a look at? Okay, I know here comes the legs, so if there's something coming in, we're waiting for it a little bit. That's perfectly all right. Hopefully you are hearing me better today, since I'm actually on a little microphone today, so it shouldn't have the echo like it did yesterday, and you probably already had to turn the sound down because my teacher voice comes out. Okay, so I'm seeing 74, then 79. So let's go to 74 first. Okay, in problem 74. All right, so this one we have the square root of x plus 1 is equal to x minus 5. Okay, so in this particular problem, what I have to be concerned with is that I've got the square root isolated here on the left-hand side, so I'm good there. So I can go ahead and square the left-hand side, and I'll be perfectly fine, but I got to be careful here. I got to make sure that I'm squaring that entire binomial as a quantity, but then I got to make sure that I expand this correctly. The common mistake is that people write x squared minus 25, okay? I need to make sure that I'm multiplying that out to create the trinomial. So if you are unsure of how that works, take the time to do it off to the side. Okay? Take the time to do it. Actually do the distributions. You'll find you get a middle term. In this case, it'll turn out to be x squared minus 10x plus 25. Left-hand side just becomes the x plus 1. Okay? Now again, you'll notice that I didn't take a look at restrictions here. I would have to look at this and say x has to be greater than -1 for it to work. But what's going to end up happening in the end anyways is I'm going to have to check my answers, especially in this case because I generated a quadratic equation here. Okay? So as I work this now, since it's a quadratic, I need to bring these two terms over to the other side so I get a 0 and solve it by factoring. I don't think you've had a single one where you've had to do anything like with a quadratic formula. And no, I'm not going to be that mean to you when it comes to a quiz or a test either. So I'm going to bring everything across. X squared, 10x minus another x is a negative 11x. 25 minus 1 will be a positive 24. Now, here again, we're in a nice position on this. I can go right to my factors because my coefficient on the x squared term or the quadratic term is a 1. It's the only time I get to do it. So I need two numbers that multiply to positive 24 that add to negative 11. Those two numbers would be 8 and 3. But because it has to be negative 11 and positive 24 to the multiplication, they both have to be negative. Okay? Both have to be negative. Okay? So from here, separate and solve. So we get x equals 3 from this piece. And we'll get x equals 8 from the other one. But now, I can't just say, hey, they're both positive numbers. They're going to work. They fit the restriction. Doesn't necessarily mean it yet. Because take a look with the 3. Okay? Look at what happens. Now, I'm going to remove the squaring here just so that we don't have that as a confusion as I go back to the original problem to check that result. Okay? So now take a look at what happens. I put a 3 in here. 3 minus 5 is negative 2. So when I do that check, I'm getting the square root of 3 plus 1. And I'm checking to see whether or not that's equal to 3 minus 5. So again, this is an important step. Hopefully everybody agrees, square root of 4. But look at the other side. We get a negative. We're in the real number system. I don't have a negative in front here to offset the negative that's already over here. So this is a principal square root. So there is not a positive number and a negative number here. It is just the square root of 4, which is 2. that we should see, everybody, doesn't work. So therefore, 3 is the extraneous solution to that. With the 8, though, since this one doesn't work, I just can't assume that the other value will work. I still want to check it, okay? So again, I'll just do it by hand here, just so everybody can see things visually. 8 plus 1, we're checking to see whether or not that's equal to 8 minus 5. 8 minus 5 is 3, so I get that side done real quick. 8 plus 1 is 9. Notice in this case, square root of 9. 3 equals 3. That definitely checks out. 8 is our result. Okay? Give me a thumbs up on that if that makes sense. Okay, looking at 54 next. All right. Okay, in this one, we have the cube root of negative 27 squared. Now, in this particular case, they're asking us just to rewrite it using rational exponents. So when you look at the final answer here, my bet is that they're not going to simplify it, but we will take a look at it as a simplification as well, okay? Because if I were actually to simplify this, I would start right here and be on my way, okay? So they want us to just rewrite it in rational exponents here. So all that's happening is that, again, as a nice review here, the index is a denominator. The power is the numerator. The value doesn't change. The only thing that I have to make sure of, though, is that when I take this out of here, since I'm using a power, I need parentheses around it. A set of parentheses, I'm going to have a wrong answer, okay? So just make it a habit that whatever is in this root, pull it out and put it in parentheses. It will save you that mistake. Now from here, I'm looking at the two values that go in that exponent. Well, the 2 is the numerator. The index value is the denominator. So our final result out of this, we would say, is negative 27 to the 2/3 power. And that should be what they list for the answer here. Let me just check that real quick. Yeah, they're leaving it as that as their value, okay? So when you get to something like that, if we see that on the quiz or on just to convert it from one to the other and not simplify, is because we have multiple ways to simplify it. So just keep that in mind. Make sure that you're reading those directions carefully. Okay. Chocho, let me know if that makes sense to you. And then as she's kind of typing in, if somebody else has got another problem, we'll take a look at that. Otherwise, we'll go ahead and start taking a look at what you can be expecting on the test on Monday. All right. Okay, give me a thumbs up if you're doing okay with the questions on the review. Okay, things are looking good. All right, now everybody, I'm going to do something here for you because you've all been the ones that have been coming in the room here. And I know once in a while that certain things can happen, like on your quiz. We had a couple of people that kind of got kicked out of the quiz because they lost their internet connection or something like that. What I want you to do is I want you to be able to contact me directly when something like that occurs, okay? So okay, I want you to create a contact for me. And so what I'm going to ask you to do when we step out of here, to please go ahead and text me with your name, and then I will make a contact for you so that if you have a question, then I know who I'm talking to, okay? Because I know that with this distance learning thing, it's very hard to be able to keep up with all the emails that can come in. Quick little question, I can do it. We can make that work. So if you would, go ahead and send me a text message once we're done with the live feed test. Here's page 1, okay? Obviously, that's not page 1. But I am looking at the problems that I've done before. What I'm going to be trying to do is I'm going to try to make this quiz or this test be an online test so you will get feedback right away, so it will actually correct it for us. I know that there are some limitations to that, so I will probably have some questions where you'll be filling in a blank, okay? Or you'll be, like you had to fill in the blank on the quiz. I might have a couple of those. I'll have some where it's probably matching. I'll probably have some that are multiple choice, but I probably will have some where there's a short answer or an essay type of question that will come up as well. Okay, now to give you identifying radicals with index values other than 2. So in other words, we're looking at things that are higher values than just square roots. So like cube roots, fourth roots, and so forth. Thank you, that's my first one. Okay. So then you're going to convert between forms. So rational exponent to radical form with those as well. Okay. Right now, as that sits, there are 7 questions on that learning target. Take that into account. Okay. So the second learning target then will be solving those radical equations, both written in radical form and in a rational exponent form. So kind of like those last problems that we just got done doing. Okay. So you can anticipate, again, same kind of thing as we'll have application problems, we'll have multiple choice, matching. I'll mix it up a little bit, and then we will have, if we've got one that you've got to do some showing work, we've got that figured out as well, okay? So that's what I want to come back then on. Oh yeah, there'll be application problems, don't worry. So then on Monday, I want us to come back together at 11, given that we can. The reason for that is that way I can kind of give you a little bit more of a heads up because I still have to generate the test in the online editor for Schoology. So it gives me a chance to kind of preview and take a look at how things are going to turn out. And I can kind of give you a heads up on how things are working. If I get a chance, I'll do some things like a practice exam and I'll put it up so you can play with. There should be some sort of an editor. So what I'll do is I'm going to be working on that over the weekend to let you know if there's one like that, to give you a chance to kind of play around. All right, everybody. So from there, let's call it good. Have a great weekend. Definitely get outside, even though it's windy. Get out there and it's chilly. Get out, get some sunlight, get some exercise, because being shut-ins like this is a big pain in the rear. So from there, everybody, let's have a great weekend, and I hope you have everything working well for you. I hope that this is working well. Take care, everybody. We'll see you on Monday.